Okay, thanks so much, and really enjoyed Edward's inspirational talk, and I'd like to move on to some more technical topics. And my name is Roger Marks, and what you're going to hear here now is a set of 3 talks that are coordinated in the form of a track, and the track is about next generation data center network fabrics. Do new technologies meet operator needs? And I'm going to do the introduction to this section. So this is up until noon. We'll have speakers, Omar Cardona and Paul Congdon will come after this on addressing hyperscale high-performance computing with RDMA and talking about some new IEEE 802 standardization on congestion isolation. And we're trying to allow some time for discussion in this segment because we're trying to look at ways to activities in the IEEE standardization activities and maybe in IETF that may be of relevance to the NANOG community. And one of our goals here is to try to reach out to the user community and find out if we're on the right track and if there's some problems that people are seeing in data center operations that could be addressed by new standardization or new technologies. And it's an effort that started with a talk I gave at the previous NANOG 75 on this topic. So this particular topic that I'm going to do first is advancing Ethernet for data center networks. And I have a lot to say about IEEE standards, so I have a disclaimer letting you know that I'm speaking in from my own views, and I'm not giving you an interpretation of IEEE standards as a formal representative of IEEE. But I do want to talk about the IEEE 802 Standardization Landman Standards Committee. It's been around since March of 1980, developing standards for LANs and MANs and some other kind of networks. And I've been active on the executive committee since 1998, so I guess that's more than half of the time that the standards committee has been around. In 802, the focus is on the lower 2 layers of the network, and the physical layer and the data link, which is essentially the MAC layer. And you can find out more about that in a standard called IEEE Standard 802. A specific, fairly new activity in IEEE 802 is called NENDICA. It's a group that I'm the chair of, and NENDICA stands for Network Enhancements for the Next Decade. And it's not a standards developing group, but it's a activity to try to build consensus, and I would say mainly look at requirements to try to understand how we can make better standards and make more relevant standards. And an important aspect of NENDICA is that it's an open activity and it's open to anybody, and we have meetings and we have teleconferences and we circulate documents, and I encourage all of you, if you're interested, to participate. You're welcome. We don't develop standards, but we may come up with documentation explaining why we think there's a role for new standards. And one of the things that you'll hear about today from Paul Congdon is how some of that documentation that we already developed has spun off into a new standardization project. The previous report that this NENDICA activity published was called the Lossless Network for Data Centers, and it tried to look at what some of the key factors were for losslessness in data centers and the applications of those kind of networks, and how we can try to manage congestion to achieve lossless networks. So that document was published, but it's subject to ongoing comments. So if you want to comment on it, feel free to do so. We'll consider those comments, and we've had discussions about reopening the activity to a revision of the report with additional information. Let me just skip over this. There's a few slides that I'm referring to here that came from the report. that just talk about the functionalities and the processes that happens in data centers. And the intention here of this slide is to try to talk about an incast problem where some kind of aggregator farms out a problem in the data center to many different distributed workers, but all the responses have to come back to the original source, and there are very strict latency requirements, but there's also this incast problem where lots of packets are arriving or addressed to the same destination at the same time, and that leads to congestion. One of the focal points that we have here, and Omar will be discussing this in much more detail in the next talk, is related to the use of RDMA, remote direct memory access, in the data center. And so what I'm showing here in this slide is a comparison to the data flow you'd see with RDMA as compared to what you'd see with a kind of a normal TCP IP application. So on the left, you'll see traffic that flows. Let's see if I can use a light here. The traffic that flows down from an application down into sockets and a transport driver and onto a NIC, and data that flows across the network on a NIC and back up through the stack at the receiving target. And this technology that has spun into modern RDMA, I think a lot of it began out of the infinity band technologies, and what came out of infinity band was this technology called RoCE, or RDMA over Converged Ethernet. And the basic idea is to be able to transfer data from memory to memory directly among two servers. And one of the things that happens is that the network driving is all done through an advanced RoCE supported NIC. And that takes the computational activity out of the server and frees it up to do other things, and makes for a much quicker and more efficient process. And so I think that originally a lot of that data traffic was developed for high performance computing and for fast storage, and originally on an entirely separate network operation. The idea of RoCE was to be able to support this thing over converged Ethernet, so to be able to put it on a network interface that was also used for other purposes within the network. And Ethernet was the technology of choice, and that's how RoCE developed. And you can sort of see in this picture the evolution from three different stacks here, from this infinity band transport protocol in the old days going over an infinity band link layer, and then with RoCE, that infinity band link layer being replaced by Ethernet link layer, and then more recently RoCE v2, which gets rid of the IB infinity-band network layer, replaces it with UDP over IP. And so this is the current implementation of RoCE, is this v2. And the problem that we see here is that this infinity-band transport protocol is dependent on the transport layer beneath it, and it's not tolerant of packet loss, and neither UDP, so UDP is not giving you any protection against packet loss, and historically Ethernet didn't either. So in this kind of environment, it became pressing on the Ethernet layer to take more and more of the responsibility and be able to provide the losslessness at that level. So skip to the next one. So back in around 2006, the IEEE 802 began a task group called the Data Center Bridging Task Group to develop improvements to the 802 technologies to be able to support these more advanced requirements on Ethernet. And the key technologies that were developed and standardized at that time were PFC, or priority-based flow control, and congestion notification and enhanced transmission selection. And I'll just quickly highlight these, but you're going to be getting more detail about these issues in the next couple of talks. But in a sort of schematic way, a data center network, you can see that you can have an incast problem, and even if you try to use ECMP or some other way to distribute your flows, you're always going to end up with congestion at the output source, because all the packets that are addressed to that source are going to result in incast at a single node. And the 802.1 standardization approach to try to address this, that's priority flow control, is designed to pause flows based on the priority level. And so it's a more advanced version of the Ethernet pause statement, which would basically be a complete pause of all traffic classes. And this thing can pause per traffic class, but what we found is that that's too crude of a tool, because there can be flows that are not contributing to the congestion, and they get paused anyway because they happen to be of the same traffic class. And that's one of the things that we've tried to look at in our activity that's led to this new standardization topic on congestion isolation that Paul will tell you more about. This figure is a bit complex, but it's trying to illustrate this problem of head-of-line blocking, where the pausing a single traffic flow will lead to a lot of congestion throughout the network. And one of the things that that we regularly hear from people that do data center operations is that the PFC adds a lot of complexity and is kind of unpredictable, and people feel that it's not something they're comfortable with. And one of the approaches that we've taken in the standardization activity is to introduce this congestion isolation, congested flow isolation, as a way to get a much more refined version of flow control that can isolate and control a single flow at a time and let the other ones to continue. These slides, I think you might want to take a further look at these offline, but this is trying to illustrate on a system-wide basis the ability of the isolation process to let the so-called victim flows continue without pause. I have here a list of some of the sources that the figures have been extracted from here. And before we proceed to the next couple of talks and Omar and Paul's talk, I want to just refer back to this NANOG activity, because I do want to encourage you to look at the report that we've issued and look at how we might want to do an update to it, and other kind of standardization activities that may be useful. And remind you that we're open process. We've got a website that's open, and you can read about our meetings and teleconferences. And we're trying to think about how we can do further outreach to the NANOG community. If we find that there's some synergy, we want to see if we can think about what we could do at future meetings and future opportunities to try to see if we can address your needs. And I would like to wrap up my talk a little bit early and turn the floor over to our next speaker. And I don't know, moderator, do you want to do an introduction or?